Hello. In this video, we're going to talk about simplifying two further trig expressions. And these are going to both be rational trig expressions, meaning we've got this fraction bar. So this is pretty complex, and there are some strategies we can use to simplify this. So we want to break it down and look at each piece individually. So let's first read it. We've got 2 sine squared beta plus sine beta minus 3 divided by the quantity 1 minus cosine squared beta minus sine beta. So there's a couple of things I noticed. The first thing I noticed is my numerator looks quadratic, right? This guy looks like ax squared plus bx plus c. We have a quadratic term, a linear term, and a constant term. So I might be able to factor my numerator with a u substitution. All right, I also notice down here in the denominator, I've got 4 trig terms, and only one of them is cosine. All of the rest are sine. So I can maybe use a Pythagorean identity to simplify that. So what do we know that cosine squared beta is equal to? Cosine squared beta. Well, we know that sine squared beta plus cosine squared beta would equal 1. So that means cosine squared beta is 1 minus sine squared beta. So I'm going to be able to sub that in for this one term. And I'm also going to look at factoring the numerator. So I'm doing a little bit of scratch work here. So my numerator, if I were to say let u equals sine of beta, then that would give us 2 u squared plus u minus 3. And this is easy for me to factor. I've got 2u and u. I'm going to put my 3 here and a 1 there. So I have 2u, I want a positive 3 and a negative 2. All right, so let's rewrite what we have. The numerator, it's going to look like this, but instead of u, I'm going to write my sine beta. So my numerator is 2 sine beta plus 3 times sine beta minus 1. And my denominator, I have 1 minus sine squared beta minus sine beta. Did I write everything I needed to write so that I would interpret this problem correctly? And I pause for a moment to remind you that I'm plugging this expression in for cosine squared beta. And there's a minus in front of cosine squared beta. So there's a minus in front of that whole expression. And what's that minus going to do? You're right, it's going to distribute. So this is now 2 sine beta plus 3 times sine beta minus 1 over, I have 1 minus 1, those are going to go away, and positive, negative, negative, so that's positive sine squared beta minus sine beta. So I have positive sine squared beta minus sine of beta. So my numerator is pretty factored. Can I factor something in the denominator? So keep in mind that sine squared beta minus sine beta, that's the same as sine beta times sine beta minus sine beta. And I can factor out a sine beta, which would leave me with sine beta minus 1. And if you're unsure on factoring that GCF, remember you can always check by multiplying it back through. So now I have 2 sine of beta plus 3 times the quantity sine of beta minus 1 divided by sine of beta times sine of beta minus 1. And here, now that I've factored these out, notice I have terms or factors that will cancel. So I can take this one step further and rewrite this as 2 sine beta plus 3 over sine of beta, because that was what was left here. So those two canceled, and I was left with 2 sine beta plus 3 over sine beta. And this is completely fine as the final answer, but I want you to recognize I could unadd that fraction, and that's 2 sine of beta over sine of beta plus 3 over the sine of beta. And taking that just a little further, those sine of betas cancel, so I have 2 plus 3, and 3 divided by sine beta could be cosecant beta. So the point is here, there are tons of manipulations. We're just trying to get it simpler. And again, it's easier to know where that stopping point is when we are in the context of an equation that we're trying to solve or an equation that we're trying to prove or verify. Let's do one more example. So in our second example in this video, where we look at simplifying trig expressions, we're going to add first and then simplify. So what I'm given is cosine x divided by 1 plus sine of x plus tangent x. We want to add these together. So thinking about algebraic operations and what we know, well, we have a fraction, and I could make that into a fraction by putting it over 1, or I could also make it into a fraction by rewriting tangent as sine over cosine. So this is the same as cosine x over 1 plus the sine of x plus tangent is sine x over cosine x. So now we have two fractions, and in order to add fractions, we need a common denominator. So I'm going to take cosine x over 1 plus sine x. I'm going to choose to multiply that by cosine x over cosine x, and I'm allowed to do this because the value I've written here in gray is equal to 1. We multiply by 1. So then I have plus my sine x over cosine x, and I'm going to multiply that by 1, formed by looking at the other denominator, which is 1 plus the sine of x over 1 plus the sine of x. So I'm multiplying by 1 to get common denominators. So I'm going to multiply each of these numerators in an effort to condense this. Now, we have these denominators in factored form, and we don't generally multiply those unless we need to. So whenever we're adding fractions and we're simplifying these expressions, we're going to simplify the top, the numerator, and we're going to leave that denominator in factored form. So this becomes cosine x times cosine x is cosine squared x. And then I have plus sine x times 1 is sine of x, and sine of x times sine of x is sine squared x. So I have all of that over my common denominator, which is 1 plus the sine of x times cosine of x. Now, looking at what we have, these parentheses here, they're not indicating distribution. That's a plus sign, so I don't have anything to distribute. They're purely associative, and I'm going to get rid of them. All right, so looking at this, we need to simplify a bit. And hopefully, some of you are looking at it and recognizing that I've got cosine squared x plus sine squared x. And what do we know about cosine squared x plus sine squared x? We know it's equal to 1, and that is a Pythagorean identity. That's a Pythagorean identity. So, this sine x is still in the numerator, and I've got this is equal to 1, so I have 1 plus sine of x over 1 plus sine of x times cosine x. So you see now why I encouraged you not to multiply this out, because it's easy for me to see, well, I have 1 plus sine x and I have a times 1 plus sine x in the denominator. So that leaves me with a 1 in the numerator and cosine x in the denominator. And this is fine as your final answer, but I can even write this more compactly. What is 1 over cosine x equal to? By reciprocal identity, it's equal to secant x. So I hope these kind of more in-depth examples give you a better idea of how to use your Pythagorean identities, your basic trig identities, your even and odd identities, as well as algebraic operations, factoring GCFs, factoring quadratics, adding fractions, getting a common denominator, all of those algebra strategies applying here to this trig. As always, email me if you have any questions. Have fun and be safe.